Hey guys, Mr. A here bringing you our first YouTube style video lesson. Yay! Okay, today I want to share with you how computers create graphics. And before we begin with what vector graphics and raster graphics are, I want to show you how I like to think about graphics. I just love Super Mario. But what I love about this illustration is that it exemplifies the whole idea of computer graphics. So let's begin with an understanding of the basic terms, pixel and vector. Pixel. In computer graphics, a pixel, dots, or picture element is a physical point in a picture. Okay, a pixel is simply an array of addressable elements in a picture. A majority of pictures that we see on our computer screen are raster images. The selfie stick that you click with your mobile phone is just one example of a raster image. An image is made up of a collection of pixels referred to as a bitmap. So what's a bitmap? Bitmap in computer graphics is a mapping from some domain, for example, a range of integers to bits, that is values which are 0 or 1. It's also called a bit array or bitmap index. The more general term, pixmap, refers to a map of pixels where each one may store 2 or more pixels, using more than 1 bit per pixel. In some contexts, the term bitmap implies a pixel, while pixmap is used for images using multiple pixels. Okay, that's a mouthful. So what is then a raster graphic? Okay, let's dig deep onto it. Raster images use bitmaps to store information. This means a large file needs a large bitmap. The larger the image, the more disk space the image file will take up. As an example, a 640 by 480 pixel image requires information to store up to 300,000 pixels, while a 3000 by 2000 image from a 6.3 megapixel digital cam needs to store a whopping 6,291,000 pixels. And we use algorithms in computers to reduce these file sizes. Image formats like JPEG and GIF are commonly compressed image formats, and scaling down these images is easy, but enlarging a bitmap makes it super pixelated and super blurry. Hence, for those images that need to be scaled in different sizes, we actually use vector graphics. So what exactly then is a vector graphic? Okay, so vector graphics use sequential commands or mathematical statements or programs which place lines or shapes in a 2D or 3D environment, and that's referred to as a vector graphic. But what vector graphics are best known for is printing, since it's composed of a series of mathematical curves. As a result, vector graphics print super crisp even when they're enlarged, and I love that. In physics, a vector is something which is a magnitude and direction. So in vector graphics, the file is created and saved as a sequence of vector statements. Rather than having a bit in the file for each bit of line drawing, we use commands which describe a series of points to be connected. As a result, a much smaller file is obtained. And some file extensions of vector graphics that we're going to be working on in the class will be .svg, EPS, PDF, AI, or DXF formats. We'll explain that later. So what's the difference between vector and raster graphics? What's the main idea? Okay, so the main difference between vector and raster graphics is this. Raster graphics are composed of pixels, while vector graphics are composed of paths, or lines that make a path. Raster graphic, such as a GIF or JPEG, is an array of pixels of various colors which together form an image. So, that being said, thanks for watching the video. Take a moment to share maybe 1 or 2 things that you did not know about a vector or raster image. But when we return to class, our objective will be to design a pixel graphic using a cool cloud-based sprite software as a way of understanding and applying vector versus raster graphics. See you next time, guys. God bless.